Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Friends, welcome to the new day lecture on the course Maritime Structures Under Fire, Blast and Explosion offered by the Department of Maritime Engineering at IIT Gandhinagar. This is lecture number 8 in this course and is a sequel lecture which is going to explain more about the fire basics. Let us quickly rewind what we learned in the previous lecture on fire chemistry. It is very interesting, friends. The reference what you see on the site now is very useful for you to understand more in detail about design of structures under fire and blast loads. Please have a look at this book published by Cambridge Scholars Publishing, Taylor and Francis Group in UK, and have a copy of this book advised to a library as well as to your design offices. Let us quickly look at the summary what we learned in the last lecture. Fire is seen as a rapid oxidation of material. It is an exothermic chemical process of combustion. Therefore, during this process of combustion, it releases heat, light and certain reaction products. The chemical reaction occurs in the combustion process, and it will continue to happen till the energy exists. The reaction will keep on going as long as there is enough heat, fuel and oxygen. These three elements are otherwise termed as arms of a fire triangle. Also friends, we understand that combustion of hydrocarbon is very highly vulnerable. Before we understand the design of structures under fire loads, let us first understand how fire is classified. Fire is also classified based on fuel. This is useful if you want to choose appropriate extinguishers for firefighting systems. Fire is also categorized based on type of burning as pool fire, jet fire, fireball and flash fire. We also understood the growth rate when fire happens. Let us try to draw the curve again and understand different stages of fire development. Let us try to plot time in the x axis and temperature in the y axis. We will draw two curves. One is the natural fire curve, which starts from here and goes as a receding end. This is the natural fire curve. The other one is the standard fire curve, now looking at this concept, we can divide them into different stages. Let us say till this point where the standard fire curve originates, we call this as ignition stage. Then closely we have a very steep growth stage, we call this as growth stage of fire, growth phase. Then when it reaches the peak, we call this stage as the burning phase of fire, and of course this phase is called the decay phase of fire, which we discussed in the last lecture as well. So, the standard fire curve is what people generally use for fire resistant design. However, the natural fire curve is different from the standard fire curve, where the backbone of the fire curve is not captured and not is a concern in the standard design fire curve. Okay? Whereas, there is a small variation of this content and the concept when it comes to hydrocarbon fire, because hydrocarbon fire are mostly fuel controlled, and because ventilation is enough available in open source, therefore, fuel control fire has a different way of behavior compared to the standard fire curve which is shown on the screen. Having said this, now let us talk about the fire dynamics and heat transfer. There are three stages by which we can model the heat transfer mechanism: conduction, convection and radiation. Let us talk about all the three slightly in detail. Conduction, convection, radiation are three heat transfer mechanisms, and the behavior of fire depends on these mechanisms. So, let us say what is conduction. Conduction actually transfers heat through solid materials. It occurs when the vibrating particles and molecules. Transfer heat energy directly, directly to the neighboring particles. That is how the heat and the fire is propagated. This is expressed nicely by Fourier law, which says Q is minus times K of dt by dx, where Q is called the heat flux expressed in watts per square meter. K is the thermal conductivity of the material, which is expressed in watts per meter Kelvin, and dt by dx is the temperature gradient. For example, heat conducting through steel beam in a building fire can significantly reduce strength and stability. That is a conduction mode. The second mode of transfer mechanism happens with convection. The convection involves movement of heat by fluid, air or gases. Movement or let us say transfer of heat by fluid, air or gases, sometimes current as well. It is a primary driver to spread fire. This is very powerful and useful in enclosed spaces. The governing equation is given by Newton's law of cooling, which is saying Q is h of Ts minus T infinity, where h is the convective heat transfer coefficient, given by watt per square meter Kelvin. Ts is the surface temperature and T infinity is the ambient air temperature. An example of convection could be smoke or hot gases rising from heating of any particle. It spreads to the entire room, touches the ceiling and upper walls and promotes rapid fire spread. This is happening because of convection. The third transfer mechanism is radiation. Friends, radiation is an emission of heat as electromagnetic waves. This can ignite nearby objects without direct physical contact. Okay, that is very important here. The governing equation is given by Stefan Boltzmann law. Which says Q is epsilon sigma t to the power 4 minus t infinity to the power 4, where epsilon is the emissivity and sigma is the Stefan Boltzmann constant. Usually this value is taken as 5.67 10 power minus 8. Units will be watts per square meter Kelvin 4. T and T infinity represent the temperatures of the radiating surface and the surrounding surface respectively. That is, T is radiating, T infinity is surrounding surface. I can give an example of this. Heat radiating from a burning structure can ignite adjacent buildings. It can ignite vegetation, leading to extensive fire spread. So, one can see this picture which explains all the three of conduction, radiation, spreading, and of course, fire spread, convection. So, all the three are different heat transfer mechanisms that happen during fire. Okay, now, fire can be also classified as, based on this understanding, we can now say fire can also be classified as fuel control and ventilation control fire. Fuel control fire occurs when there is ample oxygen available and the fire growth and intensity depend on the quantity and type of fuel. This is called fuel control fire. Typically, this fire burns until the fuel depletion occurs. Okay, that is why it is called fuel control. The other one is ventilation control fire. This occurs when the oxygen content is limitedly available. This can happen especially in enclosed spaces, not on open spaces. Okay. So, when the oxygen level quickly diminishes due to combustion, this happens. Ventilation control fire may initially burn slower. And produce significant smoke. This is the most dangerous part in fire accidents. They pose high risk of rapid intensification they pose high risk of intensifying if fresh air is admitted in the section. Now, the problem, friends, generally when there is a fire, people in a closed space, people start opening the windows, doors, etc. You are admitting more fresh air inside and that will intensify the fire. When you admit fresh air more inside, when the fresh air is admitted inside, then it can cause something called flashover or a backdraft condition. And under this condition, fire grows very severe. That is the problem here. So, understanding the distinction between these two types of fires is critical and it is very useful when you want to plan the firefighting and then designing them for appropriate fire strategies. Okay. Let us talk about classification and category of fire. So, one can see here class A fire, which essentially arises from solid materials, wood or paper or textiles. Class B fire, which essentially originates from liquids like oil, petrol, diesel. Class C from flammable gases. Class D from metals. Class E from electrical equipments, computers, etc. and class F cooking gas and so on. So, fire is categorized according to the type of fuel which we already saw. Okay, that is very important to know. International Standards Organization and National Fire Protection Association widely recognized standards for classifying fires. Understanding this classification is crucial because then it will help you to choose appropriate extinguishing methods. Now, let us look at one by one and see what extinguishers can be used for this kind of fire. Let us say, according to Indian Standard Organization 834 1999, the standard fire is classified into distinct categories purely based on the fuel involved. This classification is very useful. This is very useful to choose appropriate extinguishers, fire suppression systems, fire fighting systems and fire resistant design. So, now let us talk about the choice of extinguishers based on recommendation of this code. Extinguishers based on the recommendations of ISO 3941 of 2007. Let us talk about class A fire. We know that class A fire essentially arises from solid combustibles. Involving wood, paper, textile, rubber and plastics. Class A fire leave ash. The outproduct of this fire is ash, huge amount of ash. What extinguisher should I use? Water based extinguishers or dry chemical powder extinguishers. They are suitable for suppressing class A fire. For example, a fire in a paper storage room is best tackled using water based extinguisher because it cools the material below the ignition temperature. Let us talk about class B fire. We know this fire occurs and the source is flammable liquids. Class B fire involves flammable liquids like petrol, diesel, oil, paint and solvents, alcohol and so on. Now, the extinguisher which is recommended for this is foam extinguisher. You can also use dry chemical powder extinguisher. One can also use carbon dioxide extinguishers for this. For class B fires. For example, a petrol fire at the fuel station requires a foam extinguisher to carry out or cut off oxygen. So, if you have got any petrol station is under fire, so one could use foam extinguisher because this will help you to cut off the oxygen and therefore it suppresses fire. Okay. Let us see class C fire. The source of flammable material which causes this fire is gas. For example, it can be propane, butane, methane or hydrogen. They fall into this category. Let us see what extinguishers we can use to suppress this fire. One can use dry chemical powder extinguisher. Is primarily used. These extinguishers interrupt the chemical reaction. They delay the chemical reaction and that's how they suppress fire. For example, a propane leak causing ignition in a kitchen would require to have a dry powder extinguisher to suppress fire. You would notice that lot of restaurants having common kitchen, large mess where food is being cooked in a large volume, you will have a lot of dry powder extinguishers which are kept at different parts on the walls, at corners. People are trained how to use them, they are inspected periodic intervals and they are tested and certified. Therefore, they can be used immediately for controlling such kind of fire which arise from gases. The next kind of fire classification is class D fire. The source which occurs or causing this fire is when metals burn, this fire occurs. This involves combustible metals like magnesium, aluminum, titanium and sodium. When these metals are combust, then this kind of fire can resulting from. The extinguishers which can be used to suppress this fire could be special dry powder extinguisher, specifically metal fires. For instance, if you have a magnesium fire, in a factory or in a laboratory, it requires a special dry powder which forms a crust over the metal and prevents the oxygen contact, and that is how the fire is suppressed. Let us talk about class E fire. Which arises from electrical equipment. Although not classified separately by NEPA, this is covered under class C of NFPA. ISO classifies this fire as fire outbreaking from electrical equipments. What are the extinguishers? So, any fire caused by electrical equipment is falling under class E fire based upon ISO, whereas based on NFPA, this fire falls under category C. Okay. What are the extinguishers which we can recommend for this kind of fire? One can use carbon dioxide extinguishers. One can also use dry powder extinguishers. To control this kind of fire, because these extinguishers are non-conductive and therefore they are very safe to be used on electrical equipments. An example could be a fire caused by overheating electrical wiring. This can be extinguished by carbon dioxide extinguisher. Class F fire which arises from cooking gas and fats. This fire involves essentially cooking media. Such as vegetable oil, animal fat, generally cause this kind of fire. This can be extinguished by using wet chemical extinguishers. They create a cooling environment, they reduce temperature, create cooling environment, and prevent reignition. Okay, that is how the fire is suppressed. For example, fire from an overheated oil in a commercial kitchen fryer can be managed by simply spraying or applying wet chemical extinguisher. So, therefore, friends, selecting an appropriate fire extinguisher is an important task. Is an important task. So, one should carefully do this because all extinguishers cannot suppress all classifications of fire. If you use a wrong extinguisher, it can actually worsen the condition. Also further, comprehensive training and clear labeling of extinguisher is necessary. This is recommended by both ISO and NFPA. What extinguisher is this? What does it contain? What kind of classification of fire can suppress? It should be printed on the extinguisher barrel itself. If you look at above all the hydrocarbon fires, which are common in oil and gas facilities, they differ from these conventional fires due to two reasons. Hydrocarbon fire which occur in oil and gas facilities, they differ in two reasons. One, they differ because they have very rapid heat release rate. The HRR is quite high in this kind of. Secondly, they rapidly spread. So, in few minutes after the fire outbreaks, the fire grows to its maximum temperature and maximum energy content. So, the rapid fire growth and rapid heat release rate are two undesirable and most vulnerable properties and characteristics of hydrocarbon fire. So, examples could be coal fire, where flammable liquid burns like a torch. Due to their severity, hydrocarbon fires require advanced suppression systems. Okay? Hydrocarbon fires require advanced suppression system. So, that is where we have to understand. So, these maritime structures including ships, LNG carriers, vessels, drill ships, semi-submersibles, platforms, even offshore coastal and harbour structures, jetties where LNG terminals and carriers are offloaded, unloaded, you must have all facilities of firefighting and suppression systems appropriately so that the fire, if breaks, can be mitigated or the spread can be controlled. Okay. There is no fire-proof design. You can only control the spread of fire to limit the damage caused by fire. Fire occurrence is an accident. There is no question about that. You should avoid, but it occurs because of various unfavorable conditions. But once fire occurs, one should have a facility and the methodology of planning for two things. One, extinguish or suppress the fire. Two, prepare a good escape mechanism for people who are trapped inside to save their lives. So, we should have both ways. So, emergency response planning as well as effective suppression system. Both are required for all classification of fire, but for maritime industry they are very necessary. So, structural fire engineering should also teach us how to plan for emergency evacuation, which we will discuss in this course, and of course, how to choose effective suppression systems, which we partly discussed in the previous ones. Having said this, now let us see how do we classify industrial fires. So, industrial fires are grouped and classified into 4 forms: pool fire, jet fire, flash fire and fireballs. These classifications are not arbitrary, but based on fundamental differences. So, this classification is based on fundamental difference on how these fire originate, how these fire propagate, and how or what are the consequences of this fire on the surroundings. So, based on these 3 factors, these fire happening in industry are classified. Okay. So, the classification is essential. One may ask me, why do we classify this? This classification is essential for many reasons. One, to compute the risk assessment of the platform or of the maritime structure. To compute the risk assessment of maritime structure, you need this classification. To perform consequence analysis So, friends, there is a very interesting book on risk and reliability of offshore structures. Authored by me for CRC. Please have a look at this book. Lot of information in parallel will be available for you to learn more from this. So, the classification is important to understand the risk or assess the risk, to perform the consequence analysis, and then to design appropriate safety measures. Having said this, let us move on to release mechanism and fuel state. The primary basis for classifying industrial fire is a physical mechanism. The primary basis for classifying industrial fire is the physical mechanism by which a flammable material can be released during combustion. Each type of fire involves distinct release scenarios. For instance, pool fire involves spilled liquid. Let us say release scenarios. Talk about pool fire. This involves release of spilled liquids. forming a reservoir. Technically, we call this as a pool. When you talk about jet fire, it results in pressurized release. It creates directional flames. And they have a very high momentum of spread. The word jet itself will tell you it travels at a high speed. The physical state of fuel, where it is a liquid forming pool or a pressurized gas creating a jet or a vapor cloud dispersed in air, fundamentally determines the classification and the behavior of the resulting fire. Having said this, let us move on to the ignition timing and sequence. Another critical factor of fire classification for industrial fire is the ignition timing and sequence of the forces. Ignition timing of release of flammable material. In some scenarios, ignition occurs immediately upon release. In some cases, ignition is delayed, and that ignition timing really helps us to classify this fire. Okay, the timing significantly affects the resulting fire type. So, the timing affects the fire type as pool fire, etc. For example, immediate ignition of a pressurized gas results in jet fire. We can put it here for learning. Immediate ignition of pressurized release of gas causes jet fire. The best example is the welding gun. You must have seen the welding gun. The welding gun connected to the butane cylinder. The cylinder is open and the gas comes out and there is an ignition source given, you get a jet fire. Okay, that is a very simple example which practically you see on welding. Welding torch is another one and so on. So, ignition timing matters to classify this fire, and therefore, if the ignition time is delayed, if the timing is delayed, you get lot of inflammable material coming into play, and that can result in what we call as a flash fire or a fireball. So, it is not that friends timing is delayed, you can save or you can suppress fire. No, it can even become worse. Flash fire and fireballs are much worse scenarios compared to pool fire and jet fire. Okay. Now, let us talk about flame propagation and combustion dynamics. The way the flame propagates through the fuel and the underlying combustion dynamics also helps us to classify this fire. For example, if we talk about flash fire, flash fire involves rapid flame propagation. This has got a pre-mixed vapor cloud, whereas talk about pool fire, it has a steady diffusion rate. Above the liquid surface. So, friends, these factors what we discussed help us to classify fire of industrial fires in particular, which happens in maritime industry, oil and gas storage plants, LNG and CNG, production units, processing units, etc., which are all part of this maritime structured sub-elements. Therefore, we are now learning them these factors because these factors help us to classify this fire and also to plan for suppression systems and also to plan the structural system to have minimum effect of this fire. Okay. So, let us talk about pool fire, friends. Pool fire is defined as a turbulent diffusion burning above the pool, okay, burning above the pool of vaporized hydrocarbon. Very interesting and advantageous part here is the fuel in this case has very minimum momentum. Very minimum momentum. So, actually these fires are formed when a flammable liquid spills over a flat surface. We call that flat surface accumulation as a pool or a reservoir, and this burns steadily as long as liquid vaporizes the surface. So, pool fire burns steadily until the vaporized flammable substance exists. So, it is purely a fuel controlled fire. Okay. So, that one good thing is about it. So, we can always estimate the rate of growth and the time of fire in this case. Okay. How long the fire will sustain burning, one can easily compute because it all depends upon what is the flashover rate of the vaporized chemical or flammable liquid available there and how much in quantity it is available there. So, one can easily compute this. So, these type of fire are very common in LNG, CNG handling transporting facilities, especially harbors and ports where they have been transported using vessels and cargoes, in petrochemical plants, refineries, fuel storage facilities and maritime structures where regasification happens. So, friends, let us move on to the summary of this particular lecture and what we have learned in this lecture. This lecture is a sequel of Fire Basics as 2. In this we learnt about the factors which help us to classify fire based on ISO and NFPA. We also learned for different classification of fire what extinguishers are suitable, because this will help us to plan the emergency response guidelines and also the evacuation plan for safety of people who are stuck in an enclosed space in case of fire accidents. Further down we also learned what are the factors which help us to classify industrial fire like pool fire, jet fire, fireball, etc. So, we started discussing more in detail about the pool fire, which will continue to in the next lecture as well to understand more about the industrial fire, because this is where we are more concerned in maritime structures. Hope you have followed the lecture, and I will request you to please go through a copy of this specific book, which is very useful and informative, contains lot of message information, equations, examples and case studies of this. Please have a look at this particular book, have a reference of this in your library and advocate this to your design officers. So, have a copy, because this has got lot of examples in terms of numerical and algebraic examples to explain both fire and blast loads design of structures, and it deals essentially more in detail with hydrocarbon fire or industrial fire. Thank you very much. Namaste.